Okay, in this video I'm going to use the Simplex method to solve a minimization problem subject to some of these constraints of the form that are greater than or equal to. So I did, I think it was 5 parts of the Simplex method where we did a maximization problem. I'm assuming you're familiar with that because I'm going to use those techniques in this video. I'm going to redo a lot of it, but I'm going to go through it a little bit faster. So just a little word of warning there. You may want to take a look at those series of videos first. Okay, so we're going to minimize c equals 3x sub 1 plus 9x sub 2, subject to these constraints: 2x sub 1 plus x sub 2 greater than or equal to 8, x sub 1 plus 2x sub 2 greater than or equal to 8, and x1 and x2 both have to be greater than or equal to 0. What we're going to do is we're going to take this minimization problem and we're going to turn it into a maximization problem. That's the idea, and then we're going to use the techniques from the other video or videos. So to turn it into a maximization problem, what we do is we look at our constraints here. So we've let me box those in. So here are our constraints. What we're going to do is we're going to put the constraints along with our equation into a little matrix form, and we're going to take what's called a transpose. So let's write it down first. The first thing we do is we take our constraints, we look at the coefficients. So I've got a 2, I've got a 1, and I'm just going to put a little dash line here. Then I have my constant of 8. In front of x sub 1, I've got a 1. In front of my x sub 2 in my second constraint, I've got a 2. Again, I've got another 8. I'm going to put a little dashed line. And now what I'm going to do is I'm going to write the coefficients from the equation that I'm trying to minimize. So we have 3x sub 1, 9x sub 2, and you'll always just put a 1 down here where the c goes. Okay, so now we've got a matrix. So what we're going to do is we're going to take what's called the transpose. And what you do when you find the transpose is the original rows, row 1, row 2, row 3, those are going to turn into columns. Column 1, column 2, column 3. So let's take a look here. Okay, so my first row here had the numbers 2, 1, and 8. That's going to be my first column, 2, 1, and 8. I do the same thing with the second row. Then I've got 1, 2, and 8, so that's going to be 1, 2, and 8. And we'll do the same thing with the third row. That becomes my third column. So now I've got 3, 9, and 1. And you can put your little dashed lines right back in there. What this now gives us, it gives us a corresponding maximization problem. So the first row, instead of, we started with x sub 1 and x sub 2, I'm going to label these as y1 and y2. Now we've got the problem. These are going to be our constraints. We're going to have 2 y sub 1 plus 1 y sub 2. And instead of being greater than or equal to, they are now going to be less than or equal to. So less than or equal to 3. Then I'm going to have 1 y sub 1 plus 2 y sub 2 less than or equal to 9. And my last row here is going to correspond to what we're trying to maximize. So now we're trying to maximize, it would be 8 y sub 1 plus 8 y sub 2. And I'll set that equal to p. I don't want to use c again. I'll use a different letter for p. So we originally had this minimization problem. We've turned it into a maximization problem. And the basic idea is the solution to this maximization problem are going to be, ta-da, the same as the solutions to the minimization problem. We'll be able to get them. So it's going to help us find that. Okay, so now we're back to basically stuff that I talked about in, again, that other set of 5 videos. So just to remind you again, we have to do a couple things. We want to take our maximization equation, this 8y sub 1 plus 8y sub 2 equals p. We want p to be positive, and we want one side to be equal to 0. So I can rewrite that as negative 8y sub 1 minus 8y sub 2 plus p equals 0. And all I'm doing is just subtracting the 8y sub 1 over, the 8y sub 2 over, and I'm just reordering it. I'm putting the variables first is all I'm doing. So we have that part. Recall that we actually introduced these slack variables. So I've got 2y sub 1 plus 1y sub 2. I'm going to introduce a slack variable, but I'm actually going to use the original variables. It turns out that's what you want to do. So I'm going to add the slack variable x sub 1, and now we set that equal to 3. I do the same thing with my next equation. I would have 1y sub 1 plus 2y sub 2. Now I need to add a new slack variable. I'm going to call it x sub 2. That would be equal to 9. And again, we've got our equation that we're trying to maximize here. So now this is where we put it into a matrix form. So, and then we start doing lots of arithmetic. So again, the constraints go first. These last two equations corresponded to my constraints. So I'm going to have 2y sub 1, I've got 1y sub 2, I have 1x sub 1. Let's even label the columns. So we've got y1, y2, I would have x1, we also had x2, and then we also had this variable p. So I've got 2y sub 1 plus 1y sub 2 plus 1x sub 1. We don't have any x2s in that equation, we don't have any p's. But now we'll include our number 3 over to the right. So I always try to be a little careful on these because, man, if you just mess up one little thing, it all just turns wonky and it won't work. So I always get a little nervous. Okay, last equation, again, just coefficients. We've got 1y sub 1, we have 2y sub 2, we don't have any x sub 1s, we have 1x sub 2s. Again, there's no p in there, but we've got a 9. And if we take our equation, we have negative 8y sub 1, we have negative 8y sub 2, we don't have any x1s, no x2s, we have the coefficient on p is 1, and then we've got a 0 on the right. So I think my dash line went a little too high there. Okay, so recall now what we have to do is we have to look at the bottom row. We look to see if there are any negative values. And you look at in this case we have 2. You look at the number that is I don't know how to say, I always say it, most negative. If you take the absolute value of those negative numbers, take whichever one is bigger. Okay, so in this case it's negative 8 and negative 8. It's a tie. It doesn't matter. So I'm just going to pick on this first column. Now what we have to do now is we have to do a little competition here. We have to take the constant, recall, over here on the far right side, which is 3. We have to divide it by whatever the coefficient is of y sub 1 in that column. So in this case we would have 3 divided by 2. Well, that's just 1.5. And then we would also take 9 and divide that by 1. Well, that gives us 9. Again, we take the smaller value, so 1.5 is certainly smaller. That's going to be my pivot element. So what we want to do now is we want to get zeros everywhere else in that column beneath the pivot element. So to do that, the first thing I'm going to do is make this 2 into a 1 by doing some row operations. So again, this is all stuff I do in the other videos. I go a little bit slower. Same idea. So I basically, whatever the coefficient is, I had a 2 here, you just divide by that. So I'm going to take 1/2 of row 1, and that's going to give me my new row 1. So let's see here. Not a lot is going to change. So everything in the first row is going to get divided by 2. So I'll have a 1, a 1/2, a 1/2, a 0, a 0, and 3/2. So I'm dividing every number in that first row by 2. And then everything else stays the same. We would have 1, 2, 0, 1, 0, 9, and likewise the bottom row stays the same. Okay, this is fun stuff. Okay, so what are we trying to do? So again, let me keep my little pivot element there circled. So sometimes people complain that the numbers I use work out too nicely, so I picked these because we'll have to do a couple steps and you end up with fractions. So for better or for worse, here we go. So I want to get a 0 where the extra 1 is and the -8. So to do that, I'm going to take -1, multiply that by row 1, add that to row 2, that's going to give me my new row 2. So let's do that operation first. So the first row is going to stay just like it is, 1, 1/2, 1/2, 0, 0, and 3/2. Now if I take -1 and multiply it by 1 and add it to 1, I'm going to get 0. That's the whole reason I did that. So here come our fractions. So -1 times 1/2 is -1/2 plus 2. Well, -1/2 plus 2, that's going to give us 3/2. So if you don't feel comfortable doing this in your head, certainly write these steps off to the side because, again, the arithmetic is tedious, and especially when you're dealing with fractions. So, okay, so -1 times 1/2 will be -1/2 plus 0 will be, well, -1/2. -1 times 0 plus 1 is 1. -1 times 0 plus 0 is 0. Now, let's see, we've got -3/2 plus 9/2. 9/2, that's what, 18 over 2. So if we subtract 3 over 2, that's going to give us 15 over 2. So again, maybe take my word for it or check it off to the side. Okay, so that was took care of this row operation. To get a 0 in the bottom left corner, I would have to take 8 times the first row, add that to row 3, to get my new row 3. So that's going to be my next step here. So let's see, we would have 8 times 1 plus -8 would be 0. 8 times 1/2, that'll be 4. 4 multiplied by, 4 added to -8 will be -4. 8 times 1/2 is 4 plus 0 will be 4. 8 times 0 plus 0 is 0. 8 times 0 plus 1 is going to be 1. Let's see, 8 times 3/2, well, 8 divided by 2 is 4 times 3 is 12, plus 0 is going to give me 12. Yeehaw! So now, again, what we have to do is we have to look at our bottom row to see if there are any negative values floating around. Well, yeah, there still is, so we've got to do it one more time here. I do the same thing. I take this ratio, so I'm going to take, so now I'm focused on my second column. If I take 3/2 and divide that by 1/2, 3/2 divided by 1/2 is going to be 3. And then I do the same thing. I take 15/2 and divide that by 3/2. That's going to leave me with 15 divided by 3, or 5. Well, 3 is the smaller number, so that means my first row, second column, that's going to be my pivot element. So now I'm going to do the same thing. I'm just going to multiply this row. I'm going to get this 1/2. I'm going to make it into a 1. And then I'm going to get zeros everywhere else in that column. Okay, so to do that, I could just multiply the first row by 2. So 2 times row 1, that's going to be my new row 1. So let's do that. So again, there's just a lot of arithmetic in these problems. It's nothing, to me, the only thing that's difficult is just not making a little arithmetic mistake. So again, we're multiplying everything in the first row by 2. So 2 times 1 will be 2, 2 times 1/2 will be 1, 2 times 1/2 will be 1, 2 times 0 is 0, 2 times 0 is 0, 2 times 3/2 is going to give us 3. We're going to leave everything else alone. So just writing down all the other numbers. Okay, so I like to keep my pivot element here circled just because it helps me stay on track, helps remember what I'm doing. So there's our pivot element. And now again, I'm just going to get zeros beneath that pivot element, everywhere else in that column. So I could take, let's see, I guess I could take -3/2 times row 1 and add that to row 2. to get my new row 2. So let's do that step here. If you wanted to, and to me it would have almost, maybe, I don't know, maybe it would have been easier, maybe not. You could have just started, well, let's don't even talk about it. Sometimes there's some arithmetic shortcuts, I should say, that you can maybe take. But let's just do this way for now, because this is more efficient. So, okay, so negative 3 halves times 2, that's going to give us negative 3, plus 0, that's going to leave me with, where did I go here? Yes, okay, sorry, I'm losing my mind here. Let me even just write down my first row. I was checking my arithmetic here. I told you I get nervous on these. Okay, so let's get 0. So we'll take negative 3 over 2. We'll multiply that by 2. Add that to 0. That's going to give us negative 3. Negative 3 halves multiplied by 1 plus 3 halves will give us 0. That's what we wanted. Let's see, negative 3 halves multiplied by 1 plus a negative 1 half. Negative 3 halves plus negative 1 half is negative 4 halves, or negative 2. Anything times 0 plus 1 will be 1. Again, we'll have 0 plus 0. We'll have negative 3 halves multiplied by 3, which would be negative 9 halves. Negative 9 halves plus 15 halves would leave us with 16 over 2, or positive 3. So that's going to take care of this row operation. The next one will be a little bit easier because I don't think we're going to have to mess with the fractions here. We'll take 4 times our first row. We'll add that to row 3 to get our new row 3. So again, I see a 1, I see a negative 4. I should multiply that first row by a positive 4 and add it to negative 4 to get a 0, because that's what I'm trying to do here. Okay, so let's see. 4 times 2 will be 8, plus 0 is 8. 4 times 1 plus negative 4 is 0. 4 times 1 plus 4, that'll be 4 plus 4, or 8. Let's see, 4 times 0 plus 0. 4 times 0 plus 0 is 0. 4 times 0 plus 1 is 1. 4 times 3 is 12. Plus 12 is going to be 24. Yay, we are done, except for just interpreting. So again, we had y1, y2, and we had what? Also y3. No, just y1 and y2. I'm just looking back at our maximization problem. We only had y1 and y2. We introduced the slack variables x1 and x2, and then we had our column p. So I'm just relabeling everything. What we do now is we just follow down. So we look at the columns. So our original problem, what we started with, we were interested in finding the values for x1 and x2. That's what we were interested in. So at the bottom of the x1 column, we have the number 8. That's going to be part of the solutions. It says x1 should equal 8. x2, if we look at the bottom, all the way at the bottom, it says x2 should actually just equal 0. And now the profit, P, that's going to be equal to the number in the bottom right corner. So, okay, so instead of P, it also turns out that that's going to be the same thing as the minimization, which was, we labeled that as C. So that's now going to be our solution to this original minimization problem. It says you're going to have a minimum when x sub 1 equals 8, when x sub 2 equals 0, and your minimum value is going to be 24. So that's going to be the solution in this case. So x sub 1 equals 8, x sub 2 equals 0, and the minimum that we attain is going to be 24. And that is the end. So I'll do another one of these that's even longer, maybe like a nice little word problem. But again, so just a quick little summary of what we did here, just to remind you. Let's look at it real quick. So, simplex method, right? Again, we've got a minimization problem, and the constraints are greater than or equal to. That's what we're dealing with. We turn that minimization problem into a maximization problem, and we do that by taking a transpose of a matrix. That gives us a new set of inequalities and equations. And again, then we're just kind of off and running doing stuff that hopefully is a little bit familiar by picking out these pivot columns and pivot elements and then just getting zeros everywhere else. You try to get rid of the negative numbers at the bottom. Once that happens, once you're finally able to do that, you'll be able to read off your solution. So, okay, this is kind of a long process. Again, if you don't feel comfortable with the arithmetic, take your time. I actually had it worked out over to the side, to be completely honest, because I wanted to make sure while I was doing it, I wasn't making crazy mistakes. So, I was checking the arithmetic in my head as I went, but, take your time. I set out this morning for a little while and made sure that this problem worked out. So, no shame in scribbling off to the side and making sure that you're getting the right values here. So, as always, I hope this helps. Feel free to post comments, questions. Hopefully I can point you in the right direction, or some other good soul out there can help out.